Welcome back to Seacoast High School's remote trigonometry class. My name is Eric Fearing. I use he, him pronouns, and most of my students call me Mr. This is the second in our series of videos about competency 2, acute and obtuse triangles, benchmark 3, the laws of sines and cosines. Today we're going to work on finding missing sides from the law of sines. Last time we did missing angles, and I'm going to try and keep this one brief because we did an introduction to the law of sines last time. The law of sines is, of course, sine of A over A equals sine of B over B equals sine of C over C, and the letters don't matter as much as the relationship between the capital letter angle and the lowercase letter length of the side across from it in a triangle. So here we have triangle SCU, and we're being asked to find SC. Line segment SC connects point S and C, and without the line segment symbol on it, this just means a distance. We would probably call this little u because it's the side across from angle U. So one of our pairs is the 150-degree angle and the unknown side. Our other pair is angle C, 10 degrees, and side little c across from it, which is 4. So I'm going to write my law of sines proportion. The sine of 10 degrees over 4 is equal to the sine of 150 degrees over u. This time we don't need an inverse sign because we're not trying to get a variable out from inside the sine function, but we do have our variable in the denominator, which is a slight wrinkle in solving the proportion. We can just take the reciprocal of both sides and these will still be equal to each other. That's my favorite move to get a variable out of the denominator. To rewrite this as u over the sine of 150 degrees equals 4 over the sine of 10 degrees. In some places they teach the law of sines in this way, where it's a over the sine of A and b over the sine of b, which is upside down compared to the way I learned it, but our dear friend Miss Saragelli used it at MIT this way all the time, where finding a side means a much easier proportion. To get u by itself, we multiply by the denominator on that side, which is the sine of 150 degrees. I'm trying to avoid using a decimal approximation as much as I can, so I'm just going to write it out long form as the sine of 150 degrees. But thinking about it, the sine of 150 is just a number. We could go to the calculator and get it right now and keep shorthand with an estimate there. But I like to only round in my last step, as you may have caught on to by now. So I'm going to say that u is 4 times the sine of 150 degrees divided by the sine of 10 degrees. The only thing in our denominator is the sine of 10 degrees. Don't take an extra step here and think you can reduce the degree measurements. They are inside functions, and we really can't predict what they are. They don't change quite the same way we would expect something that we multiplied to change. So don't fall for a temptation to maybe take 150 divided by 10 and just write 15. We are going to need to key this into the calculator as the sine of 150 degrees and also the sine of 10 degrees with both of those sine expressions in our answer. So this should be relatively quick. Going to desmos.com/scientific. Going to clear out what was in here from the last lesson and just key in exactly what I've got in front of me. 4 times the sine of 150 divided by the sine of 10. And there we have it. Rounding to one decimal place, we get 11.5 units. If this said 4 miles, it would be 11.5 miles. The units are going to match whatever it was on the other side of the triangle. So there you have it. You now should be able to find missing sides using the law of sines.